Let's talk about curvature plots for a few minutes and how curvature plots can be used to diagnose surface data. So here I've constructed a series of spheres, planes, and extrusions to illustrate the concepts of curvature plots and the differences between Gaussian, mean, max, and min curvature. And I'm really not going to talk about any formulas because I'm not a mathematician, and it's not how I judge which one I should use. I'd like to illustrate with examples how each curvature plot performs, and if we can use that to judge anything with relation to surface continuity and how those things relate. Okay, so I'm just going to hit my curvature analysis here on this simple set of data. And we've got a Gaussian curvature plot created right now, okay? And the range is over here, and that stuff can matter or not matter. But as I increase or adjust the scale, I'm showing ranges of curvature values. All of this is fancy and it's nice, but what I'd like you to notice is the directions that the software decided to use to analyze the data. Data that's an extrusion, right, is being analyzed in this direction. So if we just use a quick painting tool here, data that's an extrusion is being analyzed in this direction, right? It's being analyzed in the flat direction. And since these are spheres, these could be analyzed in any number of directions. This way, this way, this way, right? But they're all the same value. But it's decided over here, when it can choose between analyzing in this direction or analyzing in this direction on a flat surface, it's decided to analyze in the flat direction. That's what Gaussian does. It looks for flat areas, okay? And to come up with the scaling value by this number, it looks at all of the data and it has to come up with a range to show, color. Okay. Now, next might be mean curvature. Okay, and how does mean curvature decide to look at things? Well, obviously here, mean curvature decides, you know what? I really like analyzing in this direction. Even on these surfaces that are flat in this direction, this direction, this direction, this direction, it still chooses to analyze in this direction, right? And the reason I know that is because this sphere here and this surface here, they get analyzed this way, not this way. Okay, so this is looking around the circle. This is also looking around the circle. Okay. Now if we take that same set of data and we look for the principal minimum curvature. So, and I haven't really adjusted the value at all here, have I? So when I look at minimum curvature means the flattest area. So it's looking for flat areas in these surfaces, and it decides to apply itself by looking in this direction. That's the direction of minimum curvature in this surface is in the flat zone. But the direction of minimum curvature in this surface could be this way, could be this way, could be this way, but they all are radial to a center point, so this gets analyzed as a sphere. But when it has a choice, are you going to analyze this direction, which would be the maximum curvature, okay, or the minimum curvature direction, which is looking for the flat spots? This decides to go in the minimum direction. Okay. And last, let's look at principal maximum amount of curvature. Principal maximum curvature. Okay, I'm going to turn the min radius limit off so it just shows me some colors here. And now we can see that here it's decided to analyze, around the radius. Here it's also decided to analyze around the same radius. Okay, it doesn't decide to go this way. In the case of an extrusion or a cylinder, it's decided to go around the circle, right? Around the circle. Around here, not necessarily in this direction, other than we have a flat plane. Okay, so based on what type of curvature you're using, mean, Gaussian, min, or max, the software decides, or the geometry tells the software, what direction to map the curvature plot. So if we bring this to a little different example here, and I've got a small surface right here, and I'll shade it. Okay, just looks like that. All right. Now, if I put a curvature plot on that, and we put a mean curvature plot, all right, and I'm going to adjust the scale, right, and try to get this to show me some colors. Okay, and right in this zone, right, it starts showing me the colors. Now, red on one side, right, blue to purple on the other side, and green is where it's flat. So that's showing to me that the area of inflection on this surface is right about here, right, where it's green or flat, right? It's going from flat this way or this way. But is it? Or is it analyzing in this direction? Or is it analyzing in this direction? The software is deciding that based on the geometry shape. And I'd just like you to take note right here. If I put this surface in this orientation, and I'm just going to show a little more of the surface boundary. Where do we think that the inflection point is in this curve? So I'll just put a locator right here with my reference create point. And I'm going to say, where do we think that spot is? And I think it's about right there, right? That's where it looks like it's inverting. And if I look now, instead of mean curvature, I look at Gaussian curvature. It puts that spot almost right on. The green almost lines up with my spot. Okay. Gaussian curvature plots indicate where you have OGs or reversals in curvature. Okay, that's what they're good at finding. If we bring this to maybe one next level, and we start talking about, well, what can curvature plots tell me about highlights? I would say that curvature plots can't tell you a lot about highlights unless you have years of experience. But what I'd like you to bring away from this short discussion is if you can use curvature plots to diagnose transitions between surfaces. Okay, because I've seen this a lot in my years. So a person will turn on a Gaussian curvature plot and look at these surfaces and say, the continuity between these is no good. These is no good, here's no good. Okay, but maybe I turn on my black and white bars and it looks pretty smooth. Well, what does this mean? It's red to green. Here's the problem with analyzing this curvature plot without a common set of rules. So the common set of rules I would like to mention is that the curvature type tells the software what direction to analyze And I would say that this surface right here is being analyzed in this direction. This surface is being analyzed in this direction. This surface, however, is not being analyzed in this direction. I know that because I'd see a similar curvature plot to this. I believe this surface is being analyzed in the plan view for this type of curvature. Then this surface, we have no idea. Okay? It could be analyzed in this direction, who knows? That direction, okay? Because the type of curvature evaluation is determining the direction of analysis on each individual surface. All right. So if we switch to principal minimum curvature, so it's showing us the flattest areas, all right, once again, we're getting surfaces that are analyzing for where the surface is the flattest. That's their premise, is to try to show flat areas on the surface, okay? I don't find a lot of use for principal minimum curvature unless I'm looking for this concept of oil canning, but we can do that with sections and some other things. But if we want to judge how surfaces flow together, all right, so how good does this surface flow into here? Does this thing have curvature that flows into here? Does this go this way? Does this go this way? And so on. That's going to be principal maximum curvature. And what maximum curvature will do is it's inherently just how it works. The scales of blended surfaces come together correctly. Okay, so this surface is being analyzed in this direction. This surface is being analyzed in this direction. And this surface is being analyzed in this direction. And when I say this surface, I was on top of each other for a reason. This direction, this direction, this direction, this direction, this direction, this direction, this direction. Okay. Same down here. This direction, this direction, this direction, this direction, that direction, and they all blend in the middle. Principal maximum is your best curvature evaluation tool to judge how your surface tension comes into a corner, how the shape of your fillet comes into the corner. Okay, this is a good looking curvature plot right here. Now I'm not saying these surfaces are perfect, but this just illustrates the difference between maximum curvature and using Gaussian curvature to judge continuity across this boundary. You can't judge continuity or transition shape between these surfaces using Gaussian, but you can judge it a little bit with using maximum, okay?